Robot Talk is the podcast that sits down with robot enthusiasts from around the world and asks them the questions you always wanted answered. Like, can I talk to the robot? And how does that thing work? Hello everyone, welcome to Robot Talk. I'm your host, Claire Asher, and this week's episode is about conversational robots. I'm finding out about the latest advances in AI and robotics that are helping robots communicate more effectively with humans. Before we get started, I'd like to invite you to join the Robot Talk community on Patreon, where I'll be sharing behind-the-scenes updates, and you can chat with me and other Robot Talk listeners. You can also sign up to support the podcast for just £5 a month. And if you do, not only will you get a warm, fuzzy feeling for helping me to keep producing and expanding the podcast, but you'll also get access to exclusive bonus episodes and lots of other cool perks. Check out patreon.com/Claire Asher to find out more. The first 20 Patreon supporters get a free sticker, so don't procrastinate, join today. So, with all that said, let's get on with this week's interview. I recently had a fascinating discussion with Gabriel Skantze from KTH Royal Institute of Technology about having natural, face-to-face conversations with robots. This week, I'm talking to Gabriel Skantze, a professor of speech communication and technology at KTH Royal Institute of Technology, working on conversational AI and human-robot interaction. Hi, Gabriel. Wonderful to have you on Robot Talk.
Hi, very nice to be on your podcast.
To get us started, what are the key features of human communication that robots need to be able to master to achieve natural face-to-face conversations?
Yeah, I think we have to start with the sort of question, why face-to-face interaction to start with? So you could imagine many other ways of interacting with robots, of course. And a lot of robots nowadays, like Tesla, Optimus, and so on, actually doesn't have a face.
Yeah.
So it's not an obvious design choice, apparently. But I think that the face is a very important communication device. We know that it is, of course, between humans. Mm-hmm. So when we say that it's a natural form of interaction, of course, what we mean is that we as humans are used to interacting this way with each other. So when we are faced with a robot, instead of learning a completely new protocol for interacting, we are using the same protocol that we are used to. Yeah. And that, of course, we have learned it since we are children, and we are also sort of learned it through evolution, how to use this way of communicating. But of course, to try to get the robot to use this way of communicating is very challenging. So there are a lot of things that needs to be designed correctly. And we as humans are, of course, extremely sensitive to when it's not done correctly, right? So we immediately notice when something is off. So that's a super big challenge, of course, when building robots that are trying to communicate in this way. So one example would be gaze, for example, gaze behavior. So humans use the gaze to coordinate and signal a lot of different things. One of them that I look a lot at is, for example, turn taking. So if you are in the middle of your turn and you need to think about what to say next, you might gaze away a little bit, and the other person takes that as a cue to know that, okay, I should wait a bit. Yeah. Whereas when they are yielding the turn to the other person, they might look at them and so on. But we can't just look at each other also all the time, because it becomes uncomfortable. So we need to do these gaze aversions every now and then, but it's not completely random when we do them and so on. So these are just some examples of things that we need to get right to build robots that can engage in this form of interaction.
Yeah. And like you said, I mean, it comes so naturally to us that it's almost hard to think of these things because they're so innate and ingrained and obvious to us. How much kind of research in this area just on how humans interact is there as a foundation for this?
There is actually a lot. And I mean, if you look at the literature, you find a lot of studies from the 70s and onwards in linguistics and psychology, looking at gaze behavior, turn taking, all these kind of things have been studied extensively. Of course, when people did these studies in the 70s, they didn't imagine that this would be useful for people building robots in the future, right? But it is very useful. It's very useful to read this research and trying to understand these mechanisms. Of course, nowadays, we often do data-driven approaches, right? So we record people and try to train models to try to do all these things. But I think without knowing enough about the actual mechanisms, I think it's not a very good approach to only do it data-driven. We also need to have an understanding of these behaviors.
Yeah. And how universal are they across cultures?
So there are some things that are universal. Definitely, we see the same kind of patterns in things like turn-taking. We have the same fundamental things going on with the gaze and, these short feedback utterances that we call back channels, like or we are nodding while listening and so on.
Yeah.
A lot of these are in principle universal, but of course the exact way they are done might vary. So it might vary how frequent they are. It might vary how long we are supposed to look at each other before we have to do gaze aversion, for example. All these things can vary between cultures. So if you would just record data between in different cultures and look at the distributions of mutual gaze, for example, you will see differences. So, of course, if we would want to have a robot that is sort of culturally sensitive, these things should be taken into account, of course.
Yeah. So in 2014, you co-founded Furhat Robotics, which is a startup that has developed a kind of humanoid robot head and torso designed for social interaction. So what initially motivated you to launch Furhat?
So originally we started, me and my colleagues, working in a European research project where the idea was to build a robot that could navigate the streets of Munich and asking people for directions.
Okay.
This was in 2010 or something, or 2009, so it was quite a few years ago. And the idea would be to make a very challenging setting from many different perspectives. And our challenge was to handle the interaction between the robot and the humans. And we were given this robot head that they had built, and we were doing an experiment with this. And it was a very traditional sort of mechatronic head that makes a lot of noise when the eyebrows are raised and so on.
Yeah.
And we were at the same time investigating alternatives then to this. We had been working a lot on animated faces that you can interact with on displays. And we knew that, of course, this is a very powerful alternative to have an animated face, because you can have much more subtle expressions. You can quickly change the appearance depending on the application and so on, which you can't do with a sort of more mechatronic face. But, of course, the problem is that a face on a screen, it's like talking to someone over Zoom or something. So it's like you're not feeling that you're talking to someone who is located together with you.
Yeah.
So what we did was to try to combine these aspects by back projecting an animated face on a mask with a projector inside the head, which was relatively novel then, because these very small projectors that fit inside the head had just come on the market. And you really need to do back projection so that you can actually rotate the head and so on while doing the projection.
Okay.
So that was the basis of it, of course. But since we had done a lot of research already on human communication and human-machine interaction, that is where we come from. We are not really roboticists to start with. But then we applied that technology to the robot, and we explored also how this enabled multi-party interaction. So since you have a head now that is located together with you, it means that you can have mutual gaze with it. You can look at it and you can see that now the robot is actually looking at me. It's not looking at the other person standing next to me. which is not the case for a face on a screen. If that face looks sort of towards the camera, everyone in the room will think that it's looking at them. So you can't have this kind of one-on-one interaction in a multi-party setting. So we came up with this Furhat robot that had this kind of design and which could have this kind of multi-party interaction. And basically, after doing that, a lot of people approached us and thought that it was a very interesting setup and wanted to buy it. And then we decided, okay, so let's start a company then and actually produce this as a product. So that's sort of the story behind it.
Oh, so, in the last, I guess, 11 years, how much has the product developed? How much has it changed?
The fundamental principles are the same. We have improved, of course, the hardware in different ways to fit everything. And of course, originally it was very much like a prototype. We really wanted the design, the shape of the head to be anatomically correct, so you can actually put on a wig or a hat. And this combined with the customization of the face and the voice means that you can create really different personalities with it and explore that. So that's on the hardware side. On the software side, we have also continuously developed it to improve different things. Of course, now with large language models, that is a big new step, because now we can suddenly very easily set up with a prompt a new personality. So you combine the flexibility of the face, the flexibility of the voice, and now the flexibility of the dialogue. You can so easily just explore different use cases for the robot.
Yeah. And that leads really nicely into my next question, which was, what kind of uses is it being put to? Is it mainly being used in research? Is it being used socially in I don't know. Where is it being used?
So we're selling it as a sort of as a research kit. In a way, you get the hardware, the software, and an API SDK, so you can program it yourself and figure out what you want to use it for. A lot of people are exploring a lot of different use cases for it, and we have also done that, also in more sort of commercial settings with companies. We worked with Deutsche Bahn at some point to set up the robot as a host on train station and airports. So that would be a very typical use case, I would say, that you would come to the train station and you need to ask for information, and there is this robot that you can ask for information. So that's one use case where it's also natural to have this kind of multi-party interaction that we talked about, right, with multiple people standing in front of the robot. We have had other use cases where the robot is doing interviews. So that's more of a one-on-one interaction. So we had working on job interviews where the robot was interviewing people for positions with the idea that the robot would perform the interview in the same way with everyone, sort of without this kind of bias, not just in how you assess the candidate, because actually the idea was not that the robot would assess you, but only do the interview. But of course, the way you do the interview can also be influenced by your thoughts about the candidate and your prejudice and so on. So
yeah, that's true. Yeah.
The idea would be that the robot would perform the interview and not being influenced by these factors. Another use case that we are exploring is together with the Karolinska Institute here. So they are educating medical students. And they are using it now. We're using it in a collaboration to simulate patients. So the robot is sort of pretending to be a patient, and they can practice how it's like to talk to a patient. And this is very much thanks to the large language models then that can sort of give life to this character. And we also use then large language models to analyze the dialogue afterwards. So after you have talked to the patient as a student, you will get feedback. So it will say, okay, these things were good, but you actually never asked about these things, or you didn't ask it in the right way, and so on. So it can become an extremely powerful sort of conversational training tool. And that could, of course, be applied to many other settings. You could train what it's like to interview someone or taking a job interview and so on.
Yeah, that's a really interesting and diverse selection of uses. One of the main uses I see for kind of social robots and humanoids is in a care setting.
Mm-hmm.
So I was imagining that it could be used as sort of a companion robot for people living in a care home or, that kind of thing.
Yeah, definitely. I think so. We have also explored a little bit in that direction. We have looked at companion robots for elderly. So we were looking at to what extent it could sort of have a more casual conversation with elderly people. And of course, again, then using large language models for that, because it's a very open conversation that could go in any direction. But it's actually surprisingly hard to have an engaging conversation with an elderly person. So, these large language models they're very good at sort of transactional dialogue where you have to accomplish something or sort of book a ticket or whatever. And also good at things like simulating a patient. But if you're going to have an engaging dialogue with someone, that I think is actually much more challenging, because it can't be these standard responses or standard questions. That quickly becomes quite boring, actually. So that I think is a very interesting challenge. And that's something we have looked further into, like how can the robot detect that the user is enjoying the interaction, that they actually find it stimulating. And of course, then again, you have this face-to-face interaction. There are a lot of cues in the face and the voice and so on of the user that you could actually analyze to try to know that. I mean, as humans, we are quite good at this, or at least if you're a good conversationalist, you can sort of read the other person and see if they seem to be interested in what you're saying, or like if you're asking boring questions and so on. So there's a lot of improvement to be done in that direction, I think, before we can actually make true companion robots, I think.
Yeah, that's such a good point. And it makes me think as well about like trying to understand what the other person wants from a conversation. Like you said, like large language models you tend to go to them because you need something, you ask them for the thing, and then they give it to you.
Yeah.
Whereas like there's this whole thing in human conversation of detecting whether, if someone's complaining about something, do they want me to provide solutions? Do they want me to just listen and kind of empathize and understand? And I mean, a lot of humans struggle to make those distinctions.
Definitely,
so I imagine it's even more difficult for robots.
Yeah, and it can be very hard to read. I mean, and sort of how do you get those preferences? Like, would you ask about them explicitly, or like? And it's, as you say, it's probably varies a lot from person to person. So yeah, that definitely remains a very big challenge, I would say.
We talk about conversation being very easy and very natural, and obviously that is the case, probably unless you're neurodivergent. And a lot of people with autism, for example, really struggle with a lot of these cues and the kind of natural flow of conversation. Could you, or are you using the Furhat robot to maybe help teach people with autism or other, neurodivergent traits to be able to pick up on these cues?
I think that's a really great use case and something we haven't really done, at least not properly yet. I was actually contacted by some people who were working on this with young adults on the autism spectrum, people who could still live like fully functional lives, but they still felt this sort of problem of communicating with people in a sort of more casual way. And they were actually doing some kind of role playing with these as a therapy. So they were saying, like, imagine that you're meeting someone and you're like opening up and so on, and training them. And they thought that having a robot doing that kind of training would be really great. We never got to do it, but it's a bit similar actually to how we are training these medical students to talk to patients, right?
Exactly.
So I think it sort of fits into this general application domain of conversational training, where you can first have a conversation and that get some kind of feedback on what you did well and what you can sort of improve on and so on.
Yeah. So we've mentioned large language models quite a bit. And one thing I've been really fascinated by as those have become very mainstream is the fact that when something can communicate in a human way, suddenly people trust it more, and they perceive it to be sentient, even though, these AI chatbots, they're not sentient, I don't believe.
No, me neither.
But because they communicate smoothly and in a human way, people assume that they have this cognition behind there that's not really there. So yeah, I mean, I think it's really interesting how that impacts trust. And then obviously there's the issues of them kind of lying or hallucinating and how that impacts trust. Do you, what do you think about these issues and how we come to trust or understand the sentience of what we're talking to with robots?
Yeah, I think it's very important that we don't fool people into believing that they are sentient. I think that can be very dangerous. And that also creates a lot of ethical issues when putting the robots in front of someone with dementia or something, where it can be harder to get this across. So there's a lot to be done there to really ensure that they are not fooled into believing that. And I think the best way of when I interact with robots, I think it's a little bit like a form of role playing. I'm using all these social cues in the way that I'm used to use them with humans, and that creates a very sort of nice affordances for me when interacting with a machine, without believing that it's actually have any feelings. And I think that works quite well. It's a little bit like if you're watching a sad movie about someone dying or so. I can still sort of cry when watching the movie, but I'm not actually believing that someone died, right? Yeah. We can sort of separate this. We can think about this on different sort of distinguish different levels of reality and fiction and so on. And I think it's still possible to have interactions with robots where we can do the same thing, basically. Yeah. So I don't think it has to be this dystopian reality where we completely sort of can't distinguish one thing from the other anymore.
Yeah. It seems like large language models have been really revolutionary in terms of conversational robotics, though.
Yeah, definitely. I mean, it's a huge improvement. Before you took forever to design these dialogues, and you use different dialogue trees or state machines or whatever you used, and you would like always have the user asking something that you haven't thought of, and it sort of ended up in some weird direction. Now the large language models have an answer for anything, which is of course both a blessing and a curse a bit, because you have this problem of hallucinations. So whatever you ask it will always have an answer, basically, even if it's something that it's not supposed to have an answer to. So I think that's the sort of downside of it. So for certain applications, like we talked about, like the virtual patients and so on, this is not much of a problem. So there are a lot of applications we can still build with these. But when it comes to very important, sensitive information where the consequence of task failure is high, I believe that we're still not really sure to what extent we can use this powerful technology.
Yeah. So talking more generally, what roles do you see social robots performing in our future societies?
Yeah, I mean, we have already touched upon a lot of different potential application, and I should say that I believe a little bit more in at least in the sort of short term, in applications where the robots, you meet them in public spaces, perhaps. There have been a lot of attempts at building social robots to sell to end consumers, to have as companions and so on in their homes, but that has actually turned out to be very challenging. So you have to push the price down a lot, of course, in order to build them. And then you have to compromise on a lot of things. And then it's also a question, like a robot in your home, like if it's a stationary robot, if it can't like go around in your home, where should it be? Should it be in your kitchen, or should you have one robot in each room? Or like the alternative is, of course, to use your smartphone instead. So I think it's very challenging to build a robot that provides something better than that, and that's the reason why this hasn't really succeeded yet, at least. But if you go to a public sort of setting, if you go to a train station or something, I mean, the alternative would be to download some kind of app for the train station. I mean, you don't want to do that.
Yeah.
So if it's just a robot, then I can just walk up to it and ask it a question. And maybe it's a mobile robot, so it sort of can go with me and show me the way or something. That, I think, is a much more powerful use case also. And then, of course, you can also afford to build a more expensive robot if it's serving a lot of different people in this setting. But there are also sort of semi-public settings like schools for education. I think is another very interesting use case that we have also explored quite a bit on, like doing language learning with robots, where you can practice conversation and so on and learn new language.
That's a good idea.
So these are some examples of where I believe we will see them.
On a similar line, I've seen robots being used as like tour guides in museums, and that seems to work quite well.
Yeah, it's a similar thing, right? It's this kind of this public setting where it makes a lot of sense.
Yeah, absolutely. Gabriel, it's been fascinating speaking to you today. I've been chatting to Gabriel Skantze from KTH Royal Institute of Technology. Thank you.
Thank you.
Thanks for listening. If you enjoy Robot Talk, please share the podcast, subscribe, and leave a review. It really helps boost the podcast, so thanks in advance. And make sure you check out @Robot Talk Pod on social media to see a photo of the Furhat robot head that Gabriel and I talked about. Make sure you tune in next week to hear the recording of the live panel discussion on humanoid robotics. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk is brought to you by the Hamlin Centre, Imperial College London.